All right, so P-2, we're just going to work with graphs of equations, different types of things. And my computer is in the screen. There we go. Still in the screen, isn't it? All right, so if you look at example 1, you have to determine whether each point lies on the line, and they've given you the equation y equals 10x minus 7. So what are you going to do to figure that out? Okay, well, you could put the equation in your calculator. Yeah, you could. You could put into the y equals part, right? And then what would you do?
See, I mean, like, obviously you wouldn't do it, like, to find out, technically where it is, but, like, you could kind of see it, whether or not.
Well, I want to know, well, there is a specific way, if you do that on the calculator, that you could then figure out is 213 an ordered pair that makes that equation true. What would you do?
Oh, you can just plug the numbers against.
So, well, that's what we're going to do algebraically, but if I'm on my calculator, what would I do?
You could go to the table.
Go to table. So once you put it in, go to second graph, which gets you the table, and then you could input the value of 2 for x and see if you get 13. If you do, then the answer is yes. If you input -1 and you get -3, the answer is yes. If you don't get those, then it's no. We're going to do it algebraically here. But yeah, that's definitely one way that you could. So we're going to take the equation, and this is my x, and this is my y. So I'm going to plug in 13 where the y is, and then 2 for the x, and then evaluate. So 2 times 10 is 20, minus 7 is 13. So does 13 equal 13?
Yes.
So yes, this ordered pair lies on the line. If it's true, it lies on the line. So then plug in this one, -3 equals 10 times -1 minus 7. What's 10 times -1? -10 plus a -7? Are those equal? No. So then no, -1, -3 will not lie on the line. All right, so then look at example 2. We're going to sketch a graph by point plotting. Well, it depends on what kind of graph that they give you, whether we're going to point plot or not. So for number 2, don't you know how to solve or how to graph this type of equation? Yeah, you do. It's linear, isn't it? Yeah, if your x and your y are to the first power, it's linear, so put into y equals mx plus b form, right? So we're going to subtract this, subtract 3x, and then we have y equals -3x plus 6. Now, if it's been, couldn't you do an xy table? So you could do that. You still have to solve the equation for y, even if you're doing an xy table. So where does this equation cross the y-axis? At +6, right? So 1, 2, 3, 4, 5, 6. So way up here. What's my slope? Yeah, so I'm going to make it -3 over 1. So that means I'm going to go down 3 to the right 1. And I'm going to cover the entire grid. And then use my straight edge and connect. Make sure you put an arrow on both sides, both ends of your line. Now the second one is already solved for y for you, but what kind of an equation should this be? X squared. What kind of a graph is that? A parabola. Now if you remember how to find the vertex, and you should know whether that opens up or down. What does it open up or down?
Up.
Why does it open up?
Because the one in front of x squared is positive.
Yeah, the number in front of x squared is positive. So it does open up. And you're going to learn shortly just how to look at that and how to adjust the general graph of y equals x squared. But for now, we're going to make an xy graph. So y equals x squared minus 2, and you're going to come up with your y value. I would suggest for this specific problem, these values, only because I personally know where the vertex is. If you know it's a parabola and you don't catch the vertex when you're doing an XY table, you have to find the vertex. Do you remember how to find the X value of the vertex? The opposite of B over 2A. It's almost part of the quadratic formula, isn't it? So the opposite of B over 2A will give you the X value of the vertex, plug it in to the equation, and get the Y value of the vertex. And then you can choose some points on either side of that. But for right now, we're going to choose this. So this is what I'm plugging into each and every time. So what is negative 2 squared? 4. 4 minus 2? 2. So one of my ordered pairs is negative 2, positive 2. And what's negative 1 squared? 1 minus 2? Negative 1. So another point is negative 1, negative 1. 0 squared is 0, minus 2 is negative 2. So there's my y-intercept starting to curve. And what's 1 squared? Everybody. 1 minus 2, negative 1. And 2 squared is 4 minus 2 is 2. So this is our vertex. We've got 1, negative 1 is a reflected point, and 2, positive 2 is a reflected point. So then connect those with a nice gentle curve. And there you go. So that's not so bad. So if you know your linear form of y equals mx plus b, you can plot that without a t-chart. Otherwise, if it's something like a parabola, you can just use an xy table. All right, flip it. So example 3 we're going to do with example 3 and example 4. Well, the whole problem is example 3. All right, so it says using a graphing utility to graph an equation, we want you to graph 2y plus x cubed equals 4x. How am I going to get that in my calculator? That's right. So the very first thing, so write yourself some notes. Number 1, solve for y. So I'm going to take the original equation, so I need to get the y term on one side by itself, so I'm going to move that x cubed. Now, could you have moved the 4x to the left and the 2y to the right? Yes, because oftentimes we like our highest degree term positive, but for our purposes it really doesn't need to be. You could choose to do that or not. Watch what happens when we graph it. It shouldn't matter. Then I end up with 2y is equal to, and I'm going to write it as 4x minus x cubed. Now how do you solve? Divide by 2, divide the whole thing by 2. So this is what I'm putting into y equals. I'm going to put in parentheses 4x minus x cubed, and then divide it by 2. So that's the very first thing I'm going to do. And then your second step, in case you forgot, so you can write this down if you want to, input into y equals on the calculator. The third step would be to press graph. And in the fourth step, you might have to adjust your viewing window. make sure that your viewing window is that standard viewing window. So make sure that you, because we did a lot of stuff in it yesterday, so make sure you have the standard viewing window. Also make sure that your stats plots is off. So if you go to second y equals, look to see if any of your stats plots are on, because you don't want those on. And then, this is what I put into my y equals. So I use parentheses around the 4x minus x cubed. You have to. If you don't, your calculator will only divide the x cubed by 2. It won't divide the 4x. And then your graph should look like this. So now pay attention to where the relative minimum and maximum are and where it crosses the x and the y axis. Get those points correct here when you're graphing it, and then just sketch the rest of it. So all I care about is where does it cross the x and y axis. So it appears to be crossing the x axis at 2 and negative 2, and it crosses the y axis at 0 and also the x axis at 0. And then its relative minimum point looks to be at negative 1, negative 2, right? And maximum at positive 1, positive 2. So that's all I need to see. So now it mimics that graph. Now if you look below here, your viewing window can distort your graph, and I kind of talked about that or intimated about that all this week. So if you look at the viewing windows down here, if you went to your viewing window and you changed it, notice that the y-axis here goes from 0 to 0.5. And it has little hash marks in between. That means the scale here is 0.1. It goes by tenths. So if you changed your viewing window right now, so go to window. So if you change this viewing window right now, and the x does the same thing. The x goes from 0 to 0.5. So your x minimum would be 0. Your maximum would be 0.5. The scale is 0.1. And do the same thing for y. Minimum is 0. Maximum is 0.5. And the scale is 0.1. And then if you hit graph again, now it's going to look like it's just a straight line graph, which is incorrect. It doesn't really show the essence of what this graph is. And so then if you change to this scale right here, look at what the x is doing. The x is going from 0 to 6, right? So go back to window. X is going from 0, the max is 6, and the scale is by 1. What's the y going from? What's the y? Look at the graph right here. What's the minimum y? Negative 3. And what's the maximum? 3. And what's the scale? 1. Now hit graph and see if you get a similar thing. So there you go. So again, it's just showing only part of our graph, not the whole graph. And then here, our graph is going negative 50 to 50, and it's got a scale of by tens, right? So change that window. So we're going from negative 50 to 50 and a scale of 10. Negative 50 to 50 and a scale of 10. And there it looks really funky, right? And what that's done is it's really pushed in the graph and taken a lot of the curve away. And then this one is really interesting. Now it's stretching the graph out. It's going from negative 1.3 to 1.3. And then it's really hard to tell what the scale is. But I would take negative 1.3 and I would divide it by 1, 2, 3, 4, 5, 6, 7. So I would take 1.3 and divide it by 7. That's how I would put that in my window if I was trying to emulate that. So like I would have negative 1.3 and 1.3. And then, oh, it didn't like that. Hang on. Let's go back to window. Let's try that again. So I have negative 1.3 and then 1.3. And then my scale, I'm going to put in 1.3 divided by, what did I say, 7. And it gives me this funky decimal, which is fine. That's the scale. And then the y is going negative 1.5, right? To positive 1.5. And then you're going to take for your scale 1.5 and divide it by how many hash marks are there? Is it 7 or is it 8? Is it 8? Looks like it's 8. So then divide it by 8, get that, and then hit graph. Does it appear to emulate that graph? Yeah. So that's how they got it. They just changed the window. Now go back to your window and put it into its standard form. Negative 10, 10, 1, and then look at it again. And now we're back to what it should look like. So my whole point with that is that your viewing window makes a difference in how your graph looks. So if you zoom in and out, just bear in mind that it's going to distort your graph. Just be aware of that. All right, then look at the very bottom. This is just put in here to remind you, and so I would highlight it. We're not really doing a problem with it. But if you're asked to identify x and y intercepts, take your original equation, and if you're doing an x-intercept, you set y equal to 0. If you're doing a y-intercept, you set x equal to 0 and solve for the other variable. So you're just putting in 0 for one of the two values. And it's always opposite. X-intercept, y is 0. Y-intercept, x is 0. All right, last page. So example 4. Let's talk about a circle. This is kind of fun on the calculator. Calculator does something funky. So in order to graph a circle on my calculator, what do you think the first thing is I'm going to have to do?
Find the center.
It'd be nice if I found the center. Now from here, hopefully you know what the center is and you can graph it yourself, right? But how do I actually get it in my calculator? Unless you have a program for circles, we can do it using the y equals. So what were you going to say?
You have to get y by itself.
You have to get y by itself. So the very first step, just like before, solve the equation for y. So I'm going to take that original equation, x squared plus y squared equals 9. And to solve for y, I have to move the x squared by subtracting it. Now this isn't linear, so I don't have to have the squared term first. So I'm going to write it as y squared equals 9 minus x squared. Have I solved for y? No. How do you solve for y? When I take the square root of the left, that'll give me y, right? But when I take the square root of the right, don't I have to remember to do a plus minus? So we end up with y equals positive and negative square root of 9 minus x squared. So I have two different things I have to put into my y equals. And so step 2, you've got y equals positive square root of 9 minus x squared. We're going to put that in first, and I want you to see what you get. Just put that one in, and I'll make sure you have a standard viewing window, number 1. So make sure that you are back at your standard viewing window. Go into y equals and clear out what we had in there before. And I want you to put in square roots. So to find your square root, it's second function x squared. And then type in 9 minus your x squared. And then when you hit graph, what happens? You only get a half a circle, right? This is very important. So this only gives you the upper semicircle. So it is imperative that we put the negative one in there, y equals negative square root of 9 minus x squared, because this is going to give us our lower semicircle. And so if you forget, you might want to write yourself a note that we plug these into the y equals. So hang on, let me get that in there. So then you might notice something, right? Negative square root of 9 minus x squared. So then I get this. What do you notice about it? It makes an oval. Look real closely at the x-axis versus the y-axis. Do you notice anything about that in the standard viewing window? Are they the same scale? They're different. right? The y-axis is a lot closer together, the little hash marks, than the x-axis, wouldn't you agree? That's why it looks like an oval. So write yourself the following steps. So then step 3. The graph looks like, you can write this whole out if you like or not. But you're going to forget why, so that's why I like to have you write it out. Looks like an ellipse. So you can use a couple of different features. My favorite for this one is you can use the zoom square. It'll square it all up. So that's what we're going to use. We're going to use the zoom squared. So if you go to your calculator, if you go into zoom, do you see that square is at 5? Hit 5, and immediately all of the tick marks are evenly distributed. So now isn't it a nice pretty little circle? There you go. All right, so go ahead and plot. What is your center? 0, 0. And then what's your radius? 3. So my center is 0, 0, and my radius is 3, just by looking at the standard equation. So then you want to go north, 1, 2, 3, south, 3, east, 3, and west, 3. And then connect those with as nice of a curve as possible. I usually have difficulties. Look at how lumpy my circle is. Oh well. That's good enough for government work. I don't have to do a good job for that, right? I'm the teacher. All right, so let's look at our word problem. Now this is, do you need the rest, what, word problem? Is that why we're saying all? Okay. All right, so let's look at that. This is actually kind of fun. There's a fun little feature in here that I really like. So, you receive a monthly salary of $2,000, which probably sounds like a lot to you right now, but it's really not, plus a commission of 10% of sales. The verbal model, here's a verbal model, wages equals salary plus commissions on sales. And algebraic models, here's your algebraic to that, relates all of that. So, we want to know if the sales are $1,480 in August, what are your wages for that month? We're going to solve it with algebra and also with the calculator. So let's start off with algebra first. How am I going to find my wages using my algebra? Plug in. So 1480, is it Y or is it X? Sales are 1480. Yeah, commission on sales. This is our commission on sales. So my sales is my X. So you might want to put your X right here and your Y right here. The commission on sales is not my X, just my sales. And so that means that this is X. So I've got Y equals 2,000 plus 0.1 times 1480. What percent is 0.1? What percent is 0.1? 10%. So cover up the last digit of 1480, and what do you have? $148. That's it. So you didn't even have to use your calculator. So then you have Y equals 2,000 plus $148, which equals $2,148. So therefore, your August wages are $2,148. Then part B says if you receive, this is part A, receive $2,225 for September, what are your sales for that month? So what does you receive represent? That's your Y. So we're going to put 2225 in for Y equals 2,000 plus 0.1x. So how do you solve? Subtract 2,000, so we get 225 equals 0.1x. And then how do you solve for x? divide by 0.1. So divide both sides by 0.1. What's 225 divided by 0.1? Not 250. 2250, right? So therefore, the September sales were $2,250. So that's all by hand. So we know what we're looking for, right? Here's how we're going to do that with our calculator. Write the following down. So the very first thing, what are you going to do? How would I do on my calculator? Well, we're running out of time, so I'm going to help you. Put the equation to y equals. And then we're going to have to create a reasonable and to do this, you know a couple of things. You know your wages are at least $2,000. And based upon our work that we did over here, we know our sales aren't going to go over $2,250. So I went ahead and created for you a viewing window. So you're going to put in X minimum is 1,000. So remember, your X are your sales, and your X max is equal to 4,000. And your X scale, I made 50. And then your Y minimum, which is your wages, I put at $1,500, which is lower than what you'd get. And your Y max is at, I went ahead and put that at 4,000. And then your Y scale is at 500. The last thing I want you to write down, just in case we don't get to it, then use value. So this is a menu. Use value, use the value feature on the calc menu. Or, depending upon the problem, so I would use value first, or you could do zoom and trace. You could zoom in and then hit trace to find your wages and sales. Now this will give you an estimate, possibly not an exact one. The value will give you an exact one. So in your Y equals, clear out both of those equations. Well, we're gonna run out of time. But the value feature is really, really nifty. Please try it tonight. Your homework is on page 21. Again, you only have, what, 5 problems this time? 2, 4, 5. Have a lovely weekend.